So 109 on the CP practice exam asks how much energy is required. Now, energy in this context, this is heat energy. So we usually use the symbol Q for heat energy. Okay. To raise the temperature of a sample, that's 46 grams. So our sample, yeah. What now? Oh, okay. Thank you. So that's Q. That's our energy factor. Here's problem number 109. And so let's see. It's asking how much energy is required. That's this Q. That's the symbol for it. Is required to change the temperature of a 46 gram sample. So we have a mass of 46.0 grams from a negative 58. So we got an initial temperature of negative 58.0 degrees C to the melting temperature. So what's our final temperature if the melting temperature is what we're looking for water? What temperature does water melt at? Or at what temperature does water melt? 0 degrees C. It freezes and melts at 0 degrees C. Okay? Alright, so the equation you need is found on page, well, this actually covers this whole range of things on page 28 of the Unit 10 notes. So this slope right here is where we're heating up ice, heating or cooling ice. So this is the equation that fits that right there. Okay? Yeah, it's kind of small on there, but I'll write it out for you. It's Q, which is the heat energy, equals the mass of the ice times the specific heat of the ice times the change in temperature of the ice. Okay? That's the equation. And anytime you're changing the temperature, not changing the physical state, so we're not talking about melting it. This is just a change in temperature of a physical state. That's the equation you use. Okay? Now the mass we have, so Q equals 46.0 G. Okay? The specific heat is actually found on the front page of your test references. The specific heat is right here for water, right? This is water. The specific heat is right here. So we're looking for the specific heat of the solid form of water. S stands for solid. G stands for, L stands for, okay. So our solid water's specific heat is one of these two. Well, our temperature was in degrees C. Let's do the one that has degrees C, okay?
So the solid water be, what is the example of solid water?
Ice. Yeah, that's the only example. Actually, believe it or not, there are different forms of ice, but we're going to go with the simplest version of that, okay? And I'm not sure. I guess all those different forms of ice actually have different CPs, but I don't know what they are. It's kind of strange, but it goes beyond the scope of the class. We're just going to stick with this one, okay? So just regular, ice out of the refrigerator would have this CP right here, okay? All right. Yes. I'm sorry, it should be 46.0. Let me just talk that over. Q equals 46.0 grams. That's this number right here for this symbol. Times the specific heat. And the specific heat for the solid water is 2.05 J. J stands for an energy unit called joules. And then we put that over degrees C times grams. Okay? Right there. Alright, so what's the change in temperature? If we're starting at an initial temperature of 58 and we're ending at a temperature of 0, what's the change in temperature? 58 degrees C. Remember this? Delta T is equal to temperature final minus temperature initial. We did that one, didn't we? In Unit 8. Okay? We could plug that in there to find our change in temperature. Temperature final is 0.00 degrees C minus temperature initial, which is negative 58.0 degrees C. So what is my change in temperature going to be? 58 degrees C. Because negative minus a negative is a positive. Okay? Alright, so we're going to plug that number in then, 58 degrees C. So if I put this over 1 and that over 1, we don't change the value, but we make it easier to do the math. What are we going to do here first before we even do the math? Cancel out. Degrees C goes away, grams go away. We're left only with units of joules, and joules is a measure of energy. That's what we're looking for. All we got to do is plug in the numbers and multiply. Zach, need to sit up. Andrew, need to sit up. Antoine, stay with me here. So you get an answer? Okay. Well, it should be hard to do the multiplication and the rounding off, right? Huh? Yeah, well, you're right. When you multiply the whole thing together. Well, let's find out. There's a good question right there. 46.0 times 2.05 times 58.0. Yeah, boy, we are going to have to use this in scientific notation, aren't we? So our answer then is 5469.4 joules. But since we need it in 3 digits, we're going to have to round off a digit in the ones place.
Where did you get the 0.4?
Did I put it in my calculator wrong? 46.0, 2.05. What?
You put it on there.
No, 2.05. 2.05. Okay. I got you. So these are... Alright, so we need to round off a number in the ones place, and when we round off a number in the ones place, we've got to write it in scientific notation. So move our decimal place to between the first and second significant digit, right there. Write our answer like this. 5.47 times 10 to the, so I move to the left, it's third power, joules. Okay? Very good.